Hi there, chemists. In this video, I'm going to talk about molar masses. So in the last video, we talked about the definition and the mole concept. Here we're starting to put it into practice, and you're going to need a periodic table in front of you. I've got mine here, my good old favourite. So let's get started. The atomic masses on the periodic table have the units grams per mole. That's from the last video, okay? And so here I've highlighted some. This particular example has a lot of significant figures I've just noticed. Usually the one that we're dealing with in the HSC has 4 significant figures. This one has a lot more. Okay, so the units that they give in mass on the periodic table are in these grams per mole, or think about it another way, if you had 1 mole of the substance, how much would it weigh? So if you had 1 mole of helium, it would weigh 4.00 grams. But if you had 1 mole of neon, 20.18 grams. Okay, it's much heavier because it contains much more neutrons and protons. Okay, and recall that these numbers are weighted average masses for each element. So it's weighted based on their abundance of each isotope. So we can say that 1 mole of oxygen 16 weighs 16 grams, but 1 mole of oxygen atoms on Earth actually weighs on average 15.9994 grams, as there's different isotopes there with differing abundances changing that average, okay? So that's why you get some funny numbers on the periodic table. Like on this actual example here, we've got 15.994, but on some, and the HSC periodic table, you see it's 16.00 because it's rounded to 4 significant figures. Stick to the HSC one because that's the one you'll have in your exam, okay? So when we calculate the molar mass of certain particles, we need a periodic table in front of us, okay? And there's several ways to calculate the atomic mass of several particles that you could be talking about, okay? Let's consider each one here. When we're talking about the molar mass of atoms, it's very simple. We just read off the atomic mass for that element from the periodic table. I've forgotten an M there. So for example, the magnesium there, if we want the molar mass of magnesium, or how much 1 mole of magnesium atoms would weigh, we go to magnesium on our periodic table and we see it's 24.31 grams per mole. So when we're talking about the molar mass of elements, nice and simple, just find that element on the periodic table and write down its atomic mass in grams per mole. When we're talking about the molar mass of molecules, what we do is we add together the atomic masses of the component atoms of the molecule from the periodic table. So if we're talking about water here, I've tried to represent water. Water has the formula H2O. So to work out the the molar mass of water, we would add 2 times the molar mass of hydrogen plus 1 times the molar mass of oxygen, which is 2 times 1.008 grams per mole plus 1 times 16.00 grams per mole. And without a calculator, let's not embarrass ourselves here, 18.016 grams per mole. Okay. So for ions, though, we read off the atomic mass from the equivalent ion from the periodic table. Okay, so when we're talking about monatomic ions, I'm thinking here. Okay, if we say what is the molar mass of sodium plus, we just read off the mass from the periodic table, 22.99 grams per mole. Because the difference is between sodium and sodium plus is the loss of 1 electron, and that mass loss is very negligible. It's 1/3000th of it. So we don't really consider the mass of electrons here to be worthy. So we still keep it at the mass of the equivalent atom. If we're talking about the molar mass of a polyatomic ion, it's the same as a molecule, okay? So the molar mass of carbonate would be 1 times the molar mass of carbon, 12.01, plus 3 times the molar mass of oxygen, okay? Don't adjust it for those extra 2 electrons either. Now we can also talk about a mole of formula units, or when we're talking about a mole of an ionic substance, okay? We're talking about a mole of those smallest possible units that we've got. For example, sodium chloride, NaCl. It's just one of each, okay? And what we do is the same as molecules. So for sodium chloride, the formula unit, the molar mass of it, we just add the mass of sodium. Even though it's an ion, we don't really worry about the electrons. So 1 times the mass of sodium is 22.99 grams per mole. And we do chlorine as 35.45 grams per mole. One of each. And we can put it in your calculator. Let me do that, because why not? Makes for a boring video. I haven't prepared this number earlier. Terrible. 58.44 grams per mole. Okay. So follow these rules and you'll be able to work out the molar mass of anything that we're talking about. Okay. Here's another image, like the ones in the last video, of a mole of certain substances. And I've put their molar mass here. So for mercury 2 oxide, lovely red colour, it's 216 grams per mole, because you've got 1 mercury and 1 oxygen. Mercury 2 oxide will just be MgO. So it's 216.6, because if we look on our periodic table, we find mercury. There it is, 200.59, and we need to add on the 1 water, so that's plus 16, gives 216.59, or 216.6 rounded to 4 significant figures. Okay, sucrose I've written about down here. It has a formula of C12H22O11, and it weighs 342.30 grams for 1 mole, as it's the sum of 12 times 12.01, or 12 times the molar mass of carbon, plus 22 times the molar mass of hydrogen, plus 11 times the molar mass of oxygen. It's just the sum of them. Sulfur's nice and easy. It's just the atom. Go to the periodic table, look at sulfur, 32.07 grams per mole. Oh, look, there's sodium chloride, which we just calculated on the last page. Copper is an element all by itself, so read straight off the periodic table, 63.55 grams per mole. Copper 2 sulfate pentahydrate. This one's a bit harder, because you've got to do the copper and the sulfate, and that's balanced because it's copper 2 and sulfate is 2 minus. Pentahydrate, so you've also got 5 waters there, and that's why, let me just check, hopefully I did it right, it should add up to 251.5. So let me just add, copper is 63.55, and plus we're going to add on 32.07 for sulfur, plus we've got, if we follow it along the formula, we've got 4 times 16, plus now we've got to add on the waters, so there's 10 hydrogens, 10 times 1.008, plus 5 oxygens, for 1 oxygen for each water, plus 5 times 16. 249.7. Oh, I must have used some different rounding there, but you get the picture. Okay? Okay. So sometimes there may be some ambiguity when we're talking about moles of certain elements here, and it shouldn't come as too much of a surprise. So a mole of a metal is simple because it's a mole of the atoms of that metal held together by metallic bonding. A mole of carbon is simple because it'll be a mole of carbon atoms covalently bonded in a network or some crazy thing. So 1 mole of carbon, no matter what structure it's in, will always be 12.01 grams per mole. Okay, the ambiguity comes with the diatomic nonmetals. When you talk about a mole of oxygen, for example, are you talking about a mole of oxygen atoms or a mole of oxygen molecules? So there's a bit of ambiguity, and you need to specify whether you're talking about atoms or molecules, because they weigh different, of course. So a mole of oxygen atoms is 16.00 grams per mole, but it's weird to just have oxygen atoms flying around. A mole of oxygen molecules, O2, is 32.00 grams per mole, double that of just the oxygen atoms. So a mole of oxygen atoms contains 2 moles of oxygen. Sorry, let me just rephrase that. A mole of oxygen molecules contains 2 moles of oxygen atoms because the formula is O2. So with those diatomics, you've got to be a bit specific. Okay, we've done this one, but let's do an example, why not? Calculate the molar mass of sodium chloride. So that formula unit, because we've got an ionic compound. Okay, we just need to read off the masses for the component ions. And they're the same as the masses of the component elements. So sodium, if we go to the periodic table, is 22.99 grams per mole. And chlorine is 35.45 grams per mole. And notice I didn't give you a formula here. I wanted you to determine that it's NaCl. And it is NaCl because it's consisting of sodium plus, it loses 1 electron to become an ion, and chloride minus. So you only need 1 of each to form a charge of 0. Okay, so therefore let me get back to my pencil. Molar mass of sodium chloride equals 22.99 plus 35.45 grams per mole. And what did I calculate that out to? Oh, I'll do it again. 22.99 plus 35.45. 58.44 grams per mole. Don't forget your units. Okay, let's talk about example number 2. The molar mass of potassium oxide. Again, I haven't given you a formula. That's the first thing that we're going to have to do. Potassium, oxygen. Opposite sides of the periodic table, so we're dealing with an ionic compound. Potassium as an ion, group 1, so it's just potassium plus, it loses 1 electron to have the stable configuration of electrons as argon, the one just before it. And we've also got oxide. Oxide gains 2 electrons to have the stable electron configuration of neon, O2 minus. How will they combine to form a neutral charge? Well, 2 minus and 1 plus, we need 2 pluses to balance out the 2 minus of that 1 oxygen. So the formula is K2O. Bit clearer there with a K. Okay, so the molar mass is going to equal 2 times, potassium is 39.10 grams per mole, plus the 1 times the oxygen, 16.00 grams per mole. Put it in our calculator, if I can talk. 2 times 39.10, and add on the 16, and we get 94.20 grams per mole. Now, my calculator, you can't see it, but it spat back at me. Well, it gave me the answer 94.2. It didn't give me the second decimal place, but I know I had that decimal place from the others because I had that second one there and I had that second one there. So I'm going to add it in there and have 4 significant figures, just like I had 4 for these ones too. 94.20, don't forget the 0. Grams per mole, don't forget the units. The molar mass of lithium carbonate, okay? Lithium, carbon, opposite sides of the periodic table. We have an ionic compound, and carbonate is a polyatomic ion. Lithium's in group 1, lithium plus. carbonate has the formula CO3 2-. Okay, so they're going to combine with 2 lithiums to 1 carbonate, Li2CO3. Okay, so the molar mass is going to equal 2 times, what is it for lithium? 6.94 grams per mole. And we need to add on the carbon, 12.01 grams per mole, and 3 oxygens, 3 times 16.00 grams per mole. Okay, put it in our calculator. 2 times 6.94 plus 12.01 for carbon plus 3 times 16 for those oxygens, 73.89. Yep, 73.89 grams per mole for the molar mass of lithium carbonate. Okay, example 4, calculate the molar mass of carbon dioxide. Oh, carbon and oxygen, same side, same right-hand side of the periodic table. It's a covalent compound, so the formula is in the name 2 for di, CO2. So the molar mass is just going to equal 1 carbon, 12.01, plus 2 oxygens, 2 times the 16.00 grams per mole. And that, I know I'm being lazy, but I'm going to use the calculator, plus 2 times 16, 44.01 grams per mole. That makes sense, and I could do that in my head, couldn't I? Okay. So those examples have shown you how to do the molar mass of these different ionic compounds or covalent compounds or just the elements by themselves. Some worked examples there, and check your understanding. Next video we're going to learn about converting between mass and moles. Okay, thank you all.